Hi, welcome. We're going to do our edible plate tectonics lab today. As you can see on our screen, this is what you should have in front of you. You'll get it off your Google Classroom. Go ahead and click on that if you haven't already pulled it up. Thank you so much. I'm going to go ahead and scroll down so you can see what we are doing. So you'll see this demonstration of how the plates move using our Milky Way candy bar. A little bit of background for you is on the screen that says an edible introduction to plate tectonics. The background information is that even though we haven't dug a hole to China or journeyed into the center of the earth, we still have a pretty good idea about what is inside of the earth. And the earth is formed billions of years ago. The matter came together. When the densest matter moved to the center of the planet, the lighter rocks remained on the surface. When everything was done, the mantle wound up being 2/3 the mass of the planet. The layers of the earth are as follows. You have your crust and your upper mantle combined, which creates our lithosphere, which is our structural layers, lithosphere, then a asthenosphere, mesosphere, and outer core and inner core. Today, we're going to refer to our layers through our structural layers, lithosphere, asthenosphere, and mesosphere. On our candy bars, you're going to have the chocolate layer represented as your lithosphere. The caramel will be represented as our asthenosphere. Our nougat, which is going to be our mesosphere, and we won't have our outer or inner cores today. As you look at this bottom paragraph right here, it says the upper layer of the Earth's crust is not the same thickness. Crust underneath the ocean is about 5 kilometers thick, while the continental crust can be up to 65 kilometers thick. The oceanic crust is made of a denser material and minerals that are than the continental crust. Together, the crust and the upper mantle are combined to create that lithosphere, and it can be about 80 kilometers deep. The lithosphere is broken into giant tectonic plates. Okay? Today, you're going to use this chocolate bar to create those tectonic lithospheric plates. All right? As it says, then the continental rock, lightweight compared to the denser fluid asthenosphere, is a layer underneath. That's going to be your caramel today. The asthenosphere is flexible. It's ooey, gooey, lava, magma. And that asthenosphere is flexible and can be pushed like silly putty by the movement deep within the earth. The convection currents are always churning within that asthenosphere. It says down here that the plates move very slowly, about 2 inches. Remember, in science, we talk about centimeters. So between 3 to 10 centimeters a year is how slowly our tectonic plates are moving. The plastic-like rock of the asthenosphere is able to move because of those convection currents I just mentioned. As we scroll down, it's just showing you our tectonic plates. There's about a dozen tectonic plates. We have very small ones like the Cocos plate and the Nazca plate, but then you have your larger ones. You have continental and oceanic, and some of these plates have both. Some plates have continental and oceanic plates together. Okay, as we keep going, you'll notice those arrows on that plate. If you don't mind, let me mention that real quick. If you see those arrows pulling away from each other on the plate, of course, that's going to be your divergent boundaries. As the arrows are coming together, colliding, that is your convergent boundaries. And then as you see an arrow up and an arrow down, that's your transform boundaries. We'll keep started. The first thing I need you to do, of course, is to unwrap your candy bar. When you unwrap your candy bar, you're going to take your candy bar and you're going to break it into 2 sections. I'm using a butter knife I already have, but you can use whatever you need with parent permission. Please take your candy bar, cut it in half, and set 1/2 aside. Now we're going to use this one for our convergent and our divergent section of this. That other one we'll come back to when we get ready for the transform boundaries. So step 1 right here, it says use your fingernail to make a few breaks into the crust. And that's exactly what we're going to do. So we're going to kind of crunch it up. And when we crunch that up, you're going to notice that those crunches and those sections are going to represent our lithospheric plates. That's exactly what our plates look like. And then the caramel that's kind of peeking through, that is going to be our asthenosphere. So the chocolate is our lithosphere, and our caramel is the asthenosphere. Again, it says observe what happens as you, I'm sorry, my screen is blocked, as you follow the directions to create 3 types of boundaries. So let's go down to number 2. At a divergent boundary, it says to demonstrate tension at the divergent boundary, you're going to gently pull on the edge of the candy bar. So we're going to pull, but do not pull it completely apart. So watch as I stretch apart, divergent, divide, divorce. You notice the prefix. So as I do this, you notice that the caramel is still visible, but the chocolate is separated. So that caramel is the asthenosphere. This is what's happening on the sea floor underneath our ocean. This is where we're getting the mid-Atlantic ridge. This would be the continent, excuse me, this would be the oceanic plates. It could be Pacific plate. This could be the North American plate. But when they're pulling apart, that lava or magma underneath the ocean is visible. And when it hits that cold ocean floor, it solidifies and creates new oceanic floor. That's why your seafloor in the center of this is going to be newer than the ocean floor on the edge towards the coast. So again, in step 2, you're pulling apart your candy bar, and you'll notice that caramel is exposing the asthenosphere, that ooey gooey layer that is being turned constantly soft because of convection currents. All right, so please draw the layers of your Milky Way candy bar right here next to box 3. Your layers should be the chocolate as the lithosphere, the caramel as the asthenosphere, and the nougat, that kind of powdery soft part, is going to be your mesosphere today. We'll give you time to draw that. Now on step 4, it says, what type of geological events would have happened at this boundary? Now, at a divergent boundary, it doesn't always happen under the ocean, but mostly it does happen under the ocean. So when it happens underneath the ocean, of course, we're going to get the seafloor spreading, and we're going to get new oceanic floor. But if this had been continental plates, and this happened in the middle of 2 continental plates, as this does happen in Africa, you're going to get what's called a rift valley. So if you have 2 continental plates pulling apart, as you can imagine, you're going to get this big divot here. And then that's going to be the rift valley. So in your divergent boundary, please circle the appropriate geological events that will occur. I'll give you a few minutes to do that. I hope you selected Rift Valley and seafloor spreading. So we're now going to go to step 5. It says push your plates back together, but I actually don't want you to do that. I want you to set down those 2, the pieces that we were just working with. Go ahead and set those down and pick up the other one that we set aside. What you're going to do next is I need you to get a knife, again, with parent permission, and you're going to go ahead and cut it in a vertical cut, all right? And then you're going to have 2 sides that almost look like Twix bars, all right? You're going to go ahead and have these for our transform boundaries section. So go ahead and have your 2 sections that look kind of like Twix bars at this point, and we're going to go through the transform boundary. It says here at step 6, to demonstrate the forces of shearing at a transform boundary, you're going to slide 1/2 up, and the other one, it says forward and backward. I'm going to go up and down. So you're going to have 1 up, and you're going to push 1 down. And you're going to notice that that caramel is really grabbing and sticking. That caramel grabbing and sticking is representing that stress and that tension that's happening at those tectonic plates. And this would be, for example, your North American plate and your Pacific Oceanic plate. Right here would be California at the San Andreas Fault. So as you're pushing one up, the other one's really trying to push down. You're going to slide and push and push and push and all that stress. And after years and years of that stress, it's going to break free and you're going to yell, earthquake, earthquake. And that is when an earthquake would happen. So anytime that stress is building up, that tension and tension is building, the longer they stay locked up, the bigger the potential earthquake that will happen and occur once it does release. So that's why they always say, oh, we're waiting for the big earthquake to happen in California, because they really haven't had one that's measured very high on the Richter scale. And that is because this force is being locked up and that those plates are being locked together. But as soon as they break free, you're going to get that earthquake result. All right, so let's go ahead and draw on step 7. It says draw your layers, but also draw your diagram. So go ahead and draw kind of your version of your transform boundary. You'll have your one vertical mark and then your other vertical and kind of have them locked together. Once you're done drawing that, we'll go ahead down to step 8. So as we just mentioned, If you have a transform boundary, one big event always occurs here. Go ahead and circle that event on your screen as you see here. All right, excellent. So I'm going to go ahead and put this one down so I can eat it later. So you had them still together. I pulled them apart. And now we're ready to do the step about convergent boundary. It's step 9. So it's step 9. Now what I want you to do is I actually want you to put your fingers on the ends back here because you really need to support that chocolate the best that you can. So now what I'd like you to do is take your 2 pieces and shove them together the best that you can and push and push and push and push until you see this uplift. That uplift is what would have happened if I had 2 continental plates crashing or colliding together. When 2 continental plates collide together, mountains are your result because their densities are very, very similar. So you don't get subduction here. You're not going to get a trench here. You could get an occasional earthquake for sure, but mainly you're going to get mountain ranges. So this is 2 continental plates colliding together to create a mountain range. Again, down at step 11, can you go ahead and draw your mountain for me? Look at your chocolate, draw and sketch your chocolate just the best that you can. And I know it really looks like a hot mess, but that's kind of showing you the different peaks and all the different formations that you would get there. As you go down to step 12, again, at this point, you had a convergent boundary. You're going to circle, again, the most likely geological event that would resemble the movement of this candy bar. And as you know, I hope you circled mountains. All right, on step 13, it says you can enjoy your crust and asthenosphere while you answer the questions below. If you want to wait and eat them after, you can. If you want to eat them during, you can. Please get permission before eating your candy bar. I know we do have some allergies out there, and of course, I want your parents to give you permission. I'm going to go ahead and put my chocolate bar down on